difference. So when you're converting, or when you're doing flow rates and they give you a volume and a time, but they give you time in minutes and it's more than an hour, there's a couple different ways to set this up and answer this question. So one of the things is, if you know that 75 minutes, 60 minutes is an hour plus another 15 minutes, that 15 minutes is a quarter hour. So you could say, okay, this is 300 milliliters over 1.25 hours. However, if your mind doesn't think that in those terms, there's another way to answer this question and others like it. And that is to take the volume over the time and then just convert minutes to hours. And I said the alternative is you could do 300 milliliters if you instinctively know that this is 1.25 hours. You'll get the same answer no matter how you do this. So 300 times 60 divided by 75 will give you 240 milliliters per hour. And then 300 divided by 1.25 will also give you the same answer. 240 milliliters per hour.
Okay, thanks for doing that one. Could you do the one below it too?
Sure. So the one below it, the 0.9% sodium chloride, 500 milliliters IV at 200 milliliters per hour. How long will the infusion take in hours and minutes? So anytime they ask you how long one of these things is going to take, you take your total IV, which is typically in milliliters. You're going to divide it by the rate. So, the rate in milliliters times the time. Okay. So for this question, it says the IV is 500 milliliters. And it's infusing at 200 milliliters per hour. Okay. Alternatively, if you prefer, you could also write this as 500 milliliters over 1, if you like to do it that way, times 1 hour, 200 milliliters. I'm just showing you that no matter how you do this, you can still get to the right answer. There's a couple of different ways to do this. So 500 divided by 200 is going to be 2.5. So no matter how you set this up, you're going to get 2.5 hours. Okay, so that's how long this will take. So if it asked you in hours and minutes, you would say 2 hours, 30 minutes. And for those of you who haven't looked at this, this is the 220, 230 extra practice, but I think it's relevant to you guys for the 130 class. So there is benefit to looking at that. And then the other thing is, let's say we started this infusion at, let's just say it was 10 or 20 at 22:30 hours. Okay. Which is 10:30 p.m. and it was on Monday. What time would it end?
I'm sorry, can you repeat the question?
Sure. What time will this infusion end?
1 o'clock.
1 o'clock on what day?
Tuesday.
You got it. Just in case you got asked something like that. Okay. Some of the campuses want you to do this in the military time. So this is 10:30 p.m. This is 1 a.m. Just in case you get asked that. If you look at the 220, 230 practice, there's a question like that on there, and that's just letting you know that that is something that sometimes can get thrown on there. the hard part is figuring out the time, and then you just have to kind of think about your clock.
I have a quick question.
Yeah.
So I am in 130 at Boyce, and my professor is Mrs. Geyer.
Okay.
I'm not sure if you ever worked with her or if you have like our list of what will be on our exam. But on her layout of what will be on the exam, at the end it says complex dosage calculation problems 2-step, and there's 5 questions. I'm not really sure what it means by complex dosage calculation 2-step. Would that be like reconstitution or?
Good question. So first of all, I don't have any, there's only one instructor at at the North Campus that I have interaction with, because she used to be at Allegheny Campus. So I don't have any interaction with any of the other campuses, at least not directly, maybe indirectly via email and stuff. So, but we all are working off of the same blueprint. When they say complex, that just means more than one step. So it doesn't necessarily mean it's hard. It just means more than one step. So I have more examples of actually, on my practice test, there are 2 what you can consider complex questions, and they're questions 24 and 25. Have you looked at the practice test at all?
I just printed it out. I didn't really get a chance to look at it yet, but I do see them.
Okay.
Are you able to go over 24 and 25, by the
Yeah.
way?
That's what I was getting ready to do anyway. So yeah, we're good.
Thank you.
You're welcome. So yeah, so 24 and 25 are considered complex multi-step because you have to do a couple of things. You have to convert, and then you have to apply, and then do a second step. So the calculations aren't necessarily any more difficult. It's just, it's just more work. So for like this one, it tells you have Dilantin 15 milligrams per kilogram as a loading dose. Then you're going to give them 300 milligrams per day. For the loading dose, how many milligrams are you to administer when the patient weighs 176 pounds? So what makes this complex is you have a patient's weight in pounds that you need to convert to kilograms first. And after you do that, you just multiply it by 15, and that's your answer. So the complexity is that you need to know to do that, because it doesn't tell you to. And what tells you to do that is the fact that it says kilograms. So let's work that out. All right. So 176-pound patient. In order to convert that to kilograms, we divide by 2.2. And I believe that gives me 80, but let's see, 176 divided by 2.2. Yeah, 80 kilograms. And then all we're going to do then is, the next thing is, because this is considered what is called a weight-based calculation, we're just going to multiply by the 15 milligrams per kilogram. So step 1, convert pounds to kilograms. Step 2, 80 times 15. And then your answer is 1,200 milligrams. And that's what you'd give as the loading dose for this particular example.
So what is the 300 milligrams per day for?
That just tells you what to do next.
Okay.
Yeah. So that's just extra information. So if they asked you, what should they receive tomorrow? 300 milligrams. And then you wouldn't even need to worry about the patient's weight in that instance. You would just do what it says to do. So good question, by the way. 25 is there. This is going to be a little bit more, a one other conversion. We have 2 different units. We have micrograms and milligrams, but let me just read through this. 500 micrograms of entecavir has been prescribed. The solution is 0.05 milligrams per milliliter. How many milliliters will we administer? So you have 500 micrograms, and then you have 0.05 milligrams per milliliter. Now, what makes this a quote unquote complex problem is we need to know how to convert, or you need to know that you can't compare these two directly. You have to make a conversion, either convert this to milligrams or convert this to micrograms. And either way you do it, as long as they're both in the same unit, it'll be right. So let's just do this one. 500 micrograms is equal to 0.5 milligrams. And what I did is I just moved my decimal 3 to the left. If you're not sure about that, just remember you have a conversion of 1,000 micrograms per milligram. And that'll help you out remembering which direction to go when you're doing these problems. Once it's in milligrams, now I can compare it to what I have available. So if you like to do the ordered over half, the order is 0.5 milligrams. The half is 0.05 milligrams times your quantity. And I think your answer is 10. Let's double check. Yeah, so what makes this problem, again, complex is the fact that you have to do a conversion before you can do the math. And then when you mentioned earlier about reconstitution is not necessarily more complex. It's just, you just need to know what to do with the information. Yeah, so this is a good, so this is something that's new for you guys this semester, and that's the flow rate questions into drop rates, okay? So it says we have the physician ordered 1440 cc's of dextrose 5% normal saline to be infused over 12 hours. And then if your tubing is labeled below, what is your drop rate in drops per minute? And then your tubing is labeled as 10 drops per milliliter. So there's a couple things you need to know about when you're calculating a flow rate or a drop rate. You need to know two pieces of information. You need to know what the flow rate is, and you need to know what the drop factor is. Now, if you're at Boyce or North or South, the other campuses, the drop factor may not always be given to you, but I think they usually will just assume, or they'll utilize what's called micro tubing. And micro tubing, the drop factor is 60 drops per milliliter. Allegheny campus, at least every test that I've seen and every test that I've produced and all the practice ones, because there's a variety of tubing available, you'll see it listed there. It'll be on the package, or it'll be listed in the text of the question. Like, so if you have the practice set that I have, number 16, where it tells you, or it has actually, I'm sorry, number 16 actually is similar to this number 20 in that it has a label, but it'll tell you specifically 10, 15, 20 drops, whatever it happens to be. So flow rate is always going to be measured in volume over time. So typically it's milliliters per hour. Sometimes it could be milliliters per minute. Drop factor is drops per milliliter. And then your drop rate is always going to be drops per minute. So the question says the physician ordered 1440 cc's to infuse over 12 hours. So what we're going to do is we're going to take the 1440 cc's, which is the same thing as ml, over 12 hours. And that's going to be my flow rate. Now, before I multiply by my drop factor, I need to simplify this. So there's a couple options that you can do. You can reduce this. So 1440 over 12 is going to be 120. So 120 milliliters per hour. Or you can convert hours to minutes. So 12 hours times 60 minutes. And you can write this as 1440 ml, 720 minutes. So either way, you're going to get to the same answer, okay? If you do this, just make sure you convert hours to minutes. And then you can proceed with the, so when I draw an arrow, I'm just indicating that I'm making a conversion, which I think most of you can see what I'm doing there. 14, I just put into the calculator 1440 divided by 12. That's where I got that. Or I did 12 times 60, which is where I got this. And so there's just there's a couple different ways to get to the same answer. Once I'm in milliliters per minute, now I can just multiply by my drop factor, which is 10. So I'm showing you both ways just so you can see what's happening here. And then I just plug it in. So 120 over 60 is 2 times 10 is 20 drops per minute. Or I can do 1440. Whoops. 1440 times 10 divided by 720. And you'll also get 20. If you get something like 19.99 or something like that, you round it to the nearest whole drop because you can't give somebody a partial drop.
Thank you.
You're welcome. Yeah, so I've gone over the Visceral Mepperdine question in other reviews, but not so far this semester. So let's go through it. So basically, all you're doing is calculating the milliliters from the Visceral, calculating the milliliters from the Mepperdine, adding them together, and then that's your answer. Now, sometimes, depending on the practice set, sometimes I have the key is wrong. So that does happen. So if you feel like you know how to do this, then just realize that that's probably what happened is I made a mistake on the key when I printed these off. So let's just do this real quick. So I'm just going to show you, you can do this dimensional analysis. You can do this ordered over half. So I'll just do it the ordered over half way. The order for the Visceral is 60 milligrams. And what I have available for Visceral is 50 milligrams. And the quantity is a milliliter. For the Mepperdine, the order is 85 milligrams. The available is 75 milligrams, and then the quantity is the 1 milliliter. So I'm going to do 60 divided by 50 times 1 gives me 1.2 milliliters. And then 85 divided by 75. And that'll give me 1.1333 repeating. And I'm just going to go ahead and round that to the nearest tenth of 1.1 milliliters. And I'm going to add these two together, 1.2 plus 1.1. And I'm going to get 2.3 milliliters as my answer. I'm just combining these two.
Thank you.
You're welcome. So it's very similar to like your insulin question where you have 10 units and 40 units. But here we're talking about, 1.2 milliliters and 1.1 milliliters. And yeah. So for a drop rate, for this one, physician ordered 500 cc's to be infused over 5 hours. The drop factor is 15. And then the flow rate in drops per minute. So because 5 hours, we do need to convert that. So remember, in order to calculate drop rate, we need flow rate and we need drop factor. So the flow rate is the 500. Remember, cc's and mLs are the same. And 5 hours. And then I told you as a prep step before you do anything, you can either reduce this to 100 milliliters per hour, or you can convert hours to minutes and do 500 milliliters over 300 minutes. And then if you do it this way, convert this to, by the way, what I'm doing here, you do not need to do. I just know that some of you prefer to look at it this way and some of you prefer to look at it this way. Whichever way you do it is fine. I'm just showing you two options. So option A, option B, we're going to get to the same answer. Multiply by the drop factor, which was 15. So 100 times 15 divided by 60 will give me 25 drops per minute. 500 times 15 divided by 300 will also give me 25 drops per minute.
Where did you get the 15 drops from?
It was stated in the question. If your tubing is labeled as 15 drops per milliliter, what will the flow rate be?
Okay, thank you.
You're welcome. For number 18, this is very similar to the one that I did earlier with the 200 milliliters per hour. This says we have an IV that's 500 milliliters. It's infusing at 125 milliliters per hour. How long will it take? You just take 500 divided by 125, and then you get 4 hours. If you were to write that out, just like if you need to see it like kind of written out, what I'm doing is I'm taking the 500 milliliters and I'm converting it using the flow rate to get to what I want. And that's where I get the 4 hours from.
So pretty much we can always do that as long as we have milliliters and like a unit of time.
Correct. Yeah. And that's how all these infusions will look. And it's, and you can rationalize it too. If you have, you have a patient that's set up and it's a 250 milliliter IV and it's infusing at 50 milliliters, that per hour, every hour they lose 50 milliliters. So you can sit there and say, okay, in an hour, it'll be down to 200. In another hour to be down to 150 and another. So you can rationalize that as well. That's what I did with this. I just said, okay, 125. I know that 4 times 125 is 500. And so that's what I did to kind of come up with this answer. But if I was stuck, this is a way to kind of do that, because then I know what I'm looking for, how long, hours. A lot of times if they're asking you like how long and they want to know a time, they'll always have to be a start time, because you can't just say arbitrarily, when will this end, and then not know when it started. And then also, if they want to know hours and minutes, they'll usually say, how long will this take in hours and minutes?
Okay, thank you.
You're welcome.
And I kind of forgot how to do these ones, but can you do number 6?
Yeah. All right. So number 6, the fun thing is I use basically the same numbers, the 500 milliliters and the 125 milliliters. And so it just seems to be a recurring theme. So I'm going to show you this, and then I'm going to show you a variation of how this question might be asked. So this is considered an intake output question. Now, if you're at one of the other campuses, they might ask a question that involves like broth and jello and custard. I do not know what constitutes, a clear liquid and how much to replace with if you're consuming those things. So when I wrote up these questions, I just kept it very simple and straightforward. And I just said, they lost this much, we're going to replace with this much. And then how much, or if they lose this much, you replace this much. They actually lost this much. How much are we going to replace? So for this person, they're on a peg tube, which I'm assuming they're not consuming, Jello and custard and things like that on their own. I don't even know if they even serve custard at a hospital setting. I don't think I've ever seen that, but I know they have Jello. So let me just show you how this would be set up. And then I'll give it, like I said, a variation. So a little formula that I kind of created to kind of help out with this is you're going to take the actual output. Okay, so what the patient actually voids over the theoretical output. So like when it says replace for every 125 milliliters of urine output, that's what I mean by theoretical output. Don't get hung up on the name there, times the replacement volume. Okay, so what was my actual output in this question? After 4 hours, we check, they voided 500 milliliters. So my actual output, 500 milliliters. My theoretical is 125 milliliters. And my replacement volume is the 40 milliliters. When I do that, I get a replacement volume of 160 milliliters.
Okay, I see it now. Thank you.
You're welcome. Now, just because I think it's fair to kind of show this, let's just do a different variation. Let's say for every let's just say 225 milliliters out, we're going to replace, oops, this supposed to be 225 out, we're going to replace with 75 milliliters. And then let's say they actually voided 200 milliliters. You'll notice that the output, the actual output is less than the theoretical output, but I'm still going to set this up exactly the same way. My actual out was 200 milliliters. My theoretical was 225. And I apologize. I can't think of another word other than saying theoretical. And if that bothers you, it's okay. You're not alone. Your nurse is not wanting to get into theory stuff, unless you're going for your master's or PhD, I guess. All right. And then multiply by my replacement volume. 200 times 75. And then divided by 225. Now, before we get to the answer, do you think the replacement volume will be more or less than 75?
Would it be more?
Okay. So here's how you know it's going to be less.
Oh, wait, I see now.
Okay. Yeah, because in order to replace with 75 milliliters, they had to at least voided 225. But since we voided less than 225, my replacement volume is going to be less than 75. Now, the reason I'm asking that extra question is just it helps to kind of you to kind of see what's going on here. Like, okay, do they need more or less water, more or less fluid, based off of this information? And so the answer comes out to 66.6666666. We're going to round that to 66.7 milliliters.
So they would need less fluid.
They would be what now?
They would need less fluid.
Right, exactly. Well, they would need, this is the appropriate amount given what the replacement volume would be. So, but they would need less than 75.
Okay, thank you.
You're welcome. Yeah, so those numbers can vary, guys, from obviously depending on what's being asked and how it's being asked. And then, some of this stuff is not like realistic, immediately my thought process goes into, okay, if they're voiding less than what my expected replacement volume is, I might be concerned that they're not getting enough blood flow to the kidney and that they might be in a state of shock. And so I'm thinking in those terms, and I'm sure clinically you're thinking that way too, but we're talking about math here. So just remember, all we're trying to do is solve some math problems.